Hello friends, welcome back to my channel. In today's session, we will learn about type of laser. So let's see types of laser. Uh, on the basis of active medium, laser is three types. As solid state laser, in solid state laser there is a laser, Ruby laser, Nd-YAG laser, tie-sapphire laser, and semiconductor laser. These are the solid state laser. Now let us see gas laser. Third type of laser on the basis of active medium is gas laser. In this gas laser, helium neon laser, argon laser, carbon dioxide laser, and nitrogen laser. These are the gas laser. Now, third laser is dye laser. In this laser, dye molecules are used as a active medium. Now, let us see the classification of of laser on the basis of mode of operation. On the basis of mode of operation, there is a two types of laser: continuous wave mode laser and pulse mode laser. In continuous wave mode, laser wave is obtained in continuous wave mode, and pulse mode laser beam is obtained in pulse form. Uh, and on the basis of laser labels, energy labels, there are two types of laser. First one is 3-label laser, and second one is 4-label laser. So these are the classification of laser on the basis of active medium, on the basis of mode of operation, and on the basis of laser label. Let us see first ruby laser. So ruby laser is what? Ruby laser is the laser which was demonstrated by Th Wyman in 1960, and this is the first working laser. And in this laser, corundum material is used as a host material, and dopants are chromium ions, and lasing wavelength is 694.3 nanometer in this laser, and pumping is done with flash lamps, and laser operates in pulse mode. Ruby laser operates in pulse mode, and in this laser flash lamp is used as a pumping source, and it is a 3-label solid state laser. It is solid state laser because active medium is used in solid form. Now let us see construction of ruby laser. Ruby laser is a crystal of aluminum oxide in which some of the aluminum ions are replaced by chromium ions. When chromium ions are doped with aluminum in aluminum oxide, then some aluminum ions are replaced by chromium ions, and this is done by doping small amounts of chromium oxide in the melt of purified aluminum oxide. When a small amount of chromium oxide is mixed in melt form of purified aluminum oxide, then we get the ruby crystal. And these chromium ions give the crystal a pink or red color. Its color depends on the concentration of chromium ions. That means the crystals which we get after doping uh, colors depends only on the concentration of chromium ions. Now let us see again construction of ruby laser. Laser rods are prepared from a single crystal of pink ruby which contains 0.05% by weight chromium. That means chromium ions is doped in 0.05% amount by weight. Aluminum oxide does not participate in the laser action; it only acts as the host material. That means in this material, aluminum oxide doesn't participate in laser action. The ruby crystal is in the form of cylinder, and the length of ruby crystal is usually 2 to 30 centimeter, and diameter is approximately 0.5 to 2 centimeter. As very high temperature is produced during the operation of the laser, the rod is surrounded by liquid nitrogen to cool the apparatus. Since during the process of lasing action, there is a lot of high temperature is produced, so to absorb the heat, liquid nitrogen is used as a cooling material. Now let us see components of ruby laser. And in components of ruby laser, first is active medium or active center. In ruby laser, chromium ions acts as a active center. And now let us see pumping source. In ruby laser, already we have told helical flash lamp is used as a pumping source in which xenon is filled. The ruby crystal is placed inside a xenon flash lamp. And third components of ruby laser is optical resonator system. The ends of ruby crystals are polished, grounded, and made flat, and the one of the ends is polished completely silvered, while the other end is partially silvered to get the output. And this two end acts as a optical resonator in this ruby laser, and thus two polished ends acts as a optical resonator of the laser. Okay. These are the parts of ruby laser. This is the helical flash lamp, and this is the ruby rod in cylindrical shape, and this is the cavity in which this ruby rod and this helical flash lamp is installed. And this is the ruby rod, and this is the helical flash lamp, and these two ends is polished here. This end is fully silvered, polish is done, and in this surface this sulfur is partially silvered, polish is done. Now let us see the working of ruby laser. And let us consider the three energy labels E1, E2, E3, and in which there is n number of electrons. And here E1 is less than, E2 is less than E3, and therefore energy level E1 is known as ground state, or it is also called lower energy state, and energy level E2 is known as metastable state, and energy level E3 is known as pump state. And initially most of the electrons are in the lower energy state E1, and only a tiny number of electrons are in the excited state E2 and E3. And this is the energy level diagram of ruby crystal. That means it is the energy levels diagram of chromium ions. This is the lower energy state, or it is also called the ground state, and this is the metastable state, and this is the excited state. It is also called short-lived state. And in this is the incident photon, and this is the emitted photon. And between these two energy levels there is a radiation less energy transition, and we get a radiation of 6943 angstrom wavelength between E2 and E1 energy levels. Now let us see next of working of ruby laser. When light energy is supplied to the laser medium, that means when a helical flash lamp is switched on, the electrons in the lower energy state or ground state even gains enough energy and jumps into pump state. That means electrons in lower energy state absorb the photon energy in the form of photon and jump into the excited state E3. The lifetime of atom in state E3 is very small, and which is in the order of 10 to the power minus 8 second. So the electrons in the pump state do not stay for long period. After a short period, they fall into the metastable state E2 by releasing radiation less energy. That means when electrons falls from higher energy state E2 to E3 to E2, then it release some energy in the form of heat. That means it is the radiationless energy. And the lifetime of metastable state E2 is in the order of 10 to the minus 3 second, which is much greater than the lifetime of pump state E3. Therefore, the electrons reach E2 much faster than they leave E3, and in this way the number of atoms in the metastable state E2 increases, and hence population inversion is achieved between energy levels E2 and E1. After some period, the electrons in the metastable state E2 falls into the lower energy state E1 by releasing energy in the form of photons, and this is called spontaneous emission of radiation. When the emitted photon interacts with the electrons in the metastable state, it forcefully makes that electron fall into the ground state E1. As a result, two photons are emitted. This is called a stimulated emission of radiation. When these emitted photons again interacted with the metastable state electrons, then four photons are produced. And because of this continuous interaction with the electrons, millions of photons are produced. Likewise, millions of electrons are stimulated to emit light, thus, the light gain is achieved, and the amplified light escapes through the partially reflected mirror to produce laser light. This is the working of ruby laser. Now, let us see the advantages of ruby lasers. From cost point of view, the ruby lasers are economical, that means it is cheaper, and beam diameter of the ruby laser is comparatively less than carbon dioxide laser, and output power of ruby laser is not less as in helium neon gas lasers. Since the ruby is in solid form, therefore there is no chance of wasting material of active medium. And these are the some advantages of ruby lasers. If there is some advantages of ruby laser, then now let us see some disadvantages of ruby laser. In ruby lasers, no significant stimulated emissions occurs until at least half of the ground state electrons have been excited to the metastable state. And this is the one disadvantage of ruby laser. Efficiency of ruby laser is comparatively low compared to other laser, and optical cavity of ruby laser is short as compared to other lasers. So these are the some disadvantages of ruby laser. Now let us see the applications of ruby laser. And one of the first applications of the ruby laser was in range finding. It is used in range finding. And due to low output power, they are class 1 lasers and so may used as toys for children's. And it can be used as a decoration piece and artistic display. And these are the some applications of ruby lasers. Friends, now let us see about Nd-YAG lasers. It is also a solid state lasers, and here Nd-YAG stands for neodymium doped yttrium aluminum garnet. And this laser, uh, in this laser, Nd-YAG is used as a laser medium, and Nd-YAG laser is a 4-level laser system, but ruby laser is a 3-level laser system. These lasers operate in both pulse and continuous wave mode, but ruby lasers operates only in pulse mode. Nd-YAG laser generates laser light commonly in the near infrared region of the spectrum at 1064 nanometers. It also emits laser light at several different wavelengths, including 1440 nanometer and 1320 nanometer, 1120 nanometer, and 940 nanometer. Now let us see the construction part of Nd-YAG lasers. So Nd-YAG laser consists of three important elements as energy source, active medium, and optical resonator. As we know that this is the three main components of every lasers: energy source, active medium, and optical resonators. So let us see what is which material is act as active medium in Nd-YAG lasers. The active medium or laser medium. Active medium is also called laser medium of Nd-YAG laser is made up of the synthetic crystalline material yttrium aluminum garnet, which is doped with a chemical element neodymium. Then we get the Nd-YAG crystal. The lower energy state electrons of neodymium ions are excited to the higher energy state to provide lasing action in the active medium. That means it is clear that lasing action is done due to neodymium atom. And next element is energy source. In Nd-YAG laser, light energy source such as flash tube or laser diodes are used as a energy source to supply energy to the active medium. In the past, flash tubes are mostly used as a pump source because of its low cost. However, nowadays laser diodes are preferred over flash tubes because of its high efficiency and low cost. Now let us see about optical resonator of Nd-YAG laser. The Nd-YAG laser crystal is placed between two mirrors, and these two mirrors are optically coated or silvered, and each mirror is silvered or coated differently. One mirror is fully silvered, whereas another mirror is partially silvered. And this is the diagram of Nd-YAG lasers. Here this is the uh, cavity in which Nd-YAG rod and flash tube is kept, and this is two mirror in which this mirror is fully silvered and this mirror is partially silvered, where an light laser beam is emitted. And this is the circuit for to switch on flash tube, and this is the ND rod, and this cavity is in the form of elliptical shape. And this is the cross sectional view of ND laser cavity. Now let us see the working of Nd-YAG lasers. Let us take the Nd-YAG crystal as active medium, and in which neodymium ions have four energy levels E1, E2, E3 and E4, where total n numbers of electron is in the neodymium ion, and the number of electrons in the energy states E1, E2, E3 and E4 will be suppose N1, N2, N3 and N4 respectively. And let us assume that energy levels will be E1 is less than, E2 is less than, E3 is less than, E4. The energy levels E1 is as known as ground state, and E2 is the next higher energy level or excited state, and E3 is the metastable state or excited state, and E4 is the pump state, or it is also called excited state. And let us assume that initially the population will be N1 is greater than, N2 is greater than, N3 is greater than N4. When flash tubes or laser diodes supplies light energy to the active medium Nd crystal, the lower energy state E1 electrons in the neodymium ions gains energy, enough energy, and moves to the pump state or higher energy state E4. And this is the energy level diagrams of neodymium ion, in which this is the ground state, this is the lower excited state, and this is the another excited state. It acts here as a metastable state, and these are the pump states. After a short period, the electrons will fall into the next lower energy state or metastable state, and E3 by releasing non-radiation energy, releasing energy without emitting photons. The lifetime of a metastable state E3 is high as compared to the lifetime of pump state E4. Therefore, the electrons reach E3 much faster than they leave E3. This results in an increase in the number of electrons in the metastable state E3, and hence population inversion is achieved between energy levels E3 and E2. After some period, the electrons in the metastable state E3 will start falling into the next lower energy state E2 by releasing photons or light. And the emission of photons in this manner is called spontaneous emission. And the lifetime of energy state E2 is very small, just like the energy state E4. Therefore, after a short period, the electrons in the energy state E2 will fall back to the ground state by releasing radiationless energy. When photon emitted due to spontaneous emission is interacted with the other metastable state electron, it stimulates that electron and makes it fall into the lower energy state by releasing the photon. As a result, two photons are released. The emission of photons in this manner is called stimulated emission of radiation. When these two photons again interacted with the metastable state electrons, four photons are released. Likewise, millions of photons are emitted. Thus, optical gain is achieved. Spontaneous emission is a natural process, but stimulated emission is not a natural process. Now, these are the working of Nd-YAG laser, or in this way, we get the laser beam from Nd-YAG laser. Let us see the advantages of Nd-YAG laser. No chance of wasting material in the active medium because here material is used in solid form, not in gas form where this occurs. Both continuous and pulse output is possible from this solid state lasers, and low power consumption. Nd-YAG lasers offers high gain. Nd-YAG lasers have good thermal properties. Efficiency of Nd-YAG laser is very high as compared to the ruby laser. Now let us see the some disadvantages of Nd-YAG lasers. The efficiency of solid state laser is very low as compared to carbon dioxide lasers, and great disadvantages of solid state laser is the divergence, which is not constant and ranges 1 milliradian to 20 milliradian. Output power is also not very high as in CO2 lasers, and due to thermal lasing in solid state laser, the power loss occurs when the rod gets too hot. Now let us see the uses of solid state lasers or Nd-YAG lasers. Nd-YAG solid state lasers usually used when drilling holes in metals. Nd-YAG pulse type solid state lasers can be used in medical applications such as in endoscopy, etc. As military application, Nd-YAG is used by target destination system. And now let us see about the gas lasers. Gas lasers are widely available in almost all power, milliwatts to megawatts, and wavelengths UV to infrared, and can be operated in pulse and in also continuous modes. Gas lasers use low density gaseous materials as a active medium, and electrical pumping is used as a energy source in these in gas lasers. Gas lasers can be made from neutral atoms like helium, neon, metal vapor, etc., ions as argon, and molecules as a carbon dioxide. Now let us see in this about helium neon laser. Helium neon laser is the first successful gas laser which was built by Ali Jawan in 1961. Helium neon laser is a four-level laser and it operates in continuous mode. Helium neon laser active medium consists of two gases which do not interact to form a molecule. Helium and neon gas mixture is taken in a tube in the ratio of 10 ratio 1. Therefore, helium neon laser is one type of atomic gas lasers. This is the construction of a helium neon lasers, in which this is the tube, or we can say it is a glass envelope in which helium neon gas mixture is kept, and this is the laser beam, and this is the output coupler, and this acts as a high reflector. and here this is the one electrode, and this is the another electrode. It is anode and it is cathode, and between these two electrode, anode and cathode, we apply high potential difference to get electron discharge as a energy source. Now let us see again the what is in construction of helium neon laser. The setup consists of a discharge tube of length 80 centimeter and bore diameter of 1.5 centimeter. That means this is the discharge tube. This is the discharge tube. The gain medium of the laser is a mixture of helium and neon gases in a 10:1 contained at a low pressure and average 50 Pascal per centimeter of cavity length in a glass envelope. The energy or pump source of the laser is provided by electrical discharge of around 1000 volts through an anode and cathode at each end of the glass tube. A current of 5 to 100 milliampere is typical for continuous wave operation. The electrical cavity of the laser typically consists of a plain high reflecting mirror at one end of the laser tube and a concave output coupler mirror of approximately 1% transmission at the other end. Now, helium neon lasers are normally small with a cavity length of around 50 centimeter to 0.5 meter and optical output powers ranging from 1 milliwatt to 100 milliwatt. And this is the energy level diagram of gas helium and neon. This is the energy level diagram of helium, and this is the energy level diagram of neon. And laser beam is achieved due to neon. And here helium acts as helium is used to excite the neon atom. Now let us see the working part of helium neon laser. When the power is switched on, an energetic electron uh, collisionally excites a helium atom to the higher state. And the excited helium atom collides with an unexcited neon atom, and the atom exchange its internal energy. This energy exchange process occurs with high probability only because of the accidental near equality of the two excitation energy of the two levels in these atoms. Thus, the purpose of population inversion is fulfilled. When the excited neon atom passes from metastable to lower level, it emits photon of wavelength 632 nanometer. And this photon travels through the gas mixture parallel to the axis of tube, and it is reflected back and forth by the mirror ends until it stimulates an excited neon atom and causes it to emit a photon of 632 nanometer with the stimulating photon. The stimulated transitions from 3s level to 2p level is laser transition. This process is continued, and when a beam of coherent radiation beam becomes sufficiently strong, a portion of it escapes through partially silvered end, and in this way we get the laser beam from this laser. And the neon atom passes to lower level 1s emitting spontaneous emission, and finally the neon atom comes to the ground state through collision with the tube wall and undergoes radiationless transitions. Now let us see the advantages of helium neon laser. Helium neon laser has a very good coherence property. And another advantage is helium neon laser can produce three wavelengths that are 1.152 micrometer, 3.391 micrometer, and 632.8 nanometer, in which the 632.8 nanometer is most common because it is visible usually in red color. Helium neon laser tube has very small length, approximately from 10 to 100 centimeter. Cost of helium neon laser is less from most of other lasers. Construction of helium neon laser is also not very complex. Now let us see the about the disadvantages of helium neon laser. So it is a relatively low power device, means its output power is low. Helium neon laser is a low gain system device, and to obtain single wavelength laser light, the other two wavelengths of laser need suppression, which is done by many techniques and devices. So it requires extra technical skill and increase the cost also. High voltage requirement can be considered its disadvantages, and escaping of gas from laser plasma tube is also its disadvantages. So these are the some disadvantages of helium neon laser. Now let us see the applications of helium neon laser. The narrow red beam of helium neon laser is used in supermarkets to read barcodes, and helium neon laser is used in holography in producing the 3D images of objects. Helium neon lasers have many industrial and scientific uses and are often used in laboratory demonstrations of optics. Helium neon lasers also used by newspapers for reproducing transmitted photographs, and it is also used in guns for target finding. So these are the some uh, applications of helium neon laser. So friends, let us see about semiconductor lasers. So let us see some introduction about semiconductor lasers. Semiconductor laser diode. The first laser diode was demonstrated in 1962 by two US groups led by Robert N. Hall at the General Electrical Research Center and by Marshall Nathan at the IBM TJ Watson Research Center. And it is especially fabricated by PN junction diode, and this diode emits laser light when it is in forward biased. Let us see the principle of semiconductor lasers. When a PN junction diode is forward biased, the electrons from N region and the holes from the P region cross the junction and recombine with each other at a junction. And during this recombination process, the light radiation, uh, that means photons, is released from a certain specified direct band gap semiconductors like gallium arsenide. This light radiation is known as recombination radiation, and the photon emitted during recombination stimulates other electrons and holes to recombine. As a result, stimulated emission takes place, which produces laser beam. And this is the PN junction diode, in which this is the P region and this is the N region, and it is biased in forward bias mode, and therefore the electrons of N regions and holes of P regions goes towards the junction, and and at junction both holes and electrons recombine and emit photon. Now let us see the classification of semiconductor lasers. So there are two types of semiconductor lasers. First one is homojunction diode laser and second one is heterojunction diode laser. Now let us see about homojunction diode lasers. So first we will see the construction of homojunction diode lasers. Homojunction diode lasers are those lasers in which P end and N end of the diode are made up of the same type of semiconductor material. For example, gallium arsenide material. They use direct band gap semiconductor material uh, as gallium arsenide, and p-n junction acts as a active medium in this homojunction diode laser, and it applied voltage is given through metal contacts on both surfaces of the diode, and pulse beam of laser of 8400 angstrom is produced, with this homojunction diode lasers. And this is the construction of homojunction diode lasers, in which this is the p type region layer and this is the n type layer, in which same type of material gallium arsenide is used, and this region acts as a active region, and where laser beam is produced. This laser beam is produced when this p-n junction diode is in the forward biased mode. This is the construction of homojunction diode laser. The photon emission is stimulated in a very thin layer of p-n junction in order of few microns. The electrical voltage is applied to the crystal through the electrode fixed on the upper surface, as we have already known in previous slide. The end faces of the junction diode are well polished and parallel to each other. They act as an optical resonator through which the emitted light comes out. And now let us see the working of homojunction diode laser. In this working, this shows the energy level diagram of p-n junction diode, in which this represents the p region of energy level diagram, and this shows the energy level diagram of n region. Here, when we applied forward biasing in p-n junction diode, then electrons of conduction band of n region uh, and holes of valence band of p region goes towards the junction and recombine to each other, and in this due to this recombination laser beam is emitted through this active region. When the PN junction is forward wired with the large applied voltage, the electrons and holes are injected into junction region in a considerable concentration. The region around the junction contains a large amount of electrons in the conduction band and large amount of holes in the valence band. If the population density is high, a condition of population inversion is achieved. The electrons and hole recombine with each other, and these recombinations produce radiation in the form of light. When the forward bias voltage is increased, more and more light photons are emitted and the light population intensity becomes stronger. And these photons will trigger a chain of stimulated recombination, resulting in the release of photons in phase. And this photons moving at the plane of the junction travels back and forth by rejection between two sides placed parallel and opposite to each other and grow in strength. After gaining enough strength, it gives out the laser beam of wavelength 8400 angstrom, and the wavelength of laser light is given by Eg is equal to h nu, and we can write nu as c by lambda. Therefore, lambda is equal to sc by Eg, and with the help of this formula, we can find the wavelength of laser beam that is emitted by homojunction diode laser. Here Eg is the band gap energy, and which is in joule. These are the working parts of homojunction diode laser. Now let us see the advantages of homojunction lasers. So first advantages is it is very small in dimension. The arrangement is simple and compact, and second advantage is it exhibits high efficiency, and third one is the laser output can be easily increased by controlling the junction current, and it is operated with laser power than lesser power, sorry, it is operated with lesser power than ruby and carbon dioxide lasers. It requires very little auxiliary equipment, and it can have a continuous wave output or pulsed output. And this is the some advantages of homojunction diode laser. Now let us see the some disadvantages of this homojunction diode laser. It is difficult to control the mode pattern and mode structure of laser. This is the one disadvantages. Laser beam has large divergence. This is the another disadvantages. The purity and the monochromaticity are lower than other types of lasers. The threshold current density is very large and it has poor coherence and poor stability. So these are the some disadvantages of homojunction diode lasers. Now let us see some application of this type of diode laser. It is widely used in fiber optic communication and it is used to heal the wounds by infrared radiation. It is also used as a painkiller. It is used in laser printers and CD writing and reading. So these are the some applications of homojunction diode lasers. Now let us see the another type of semiconductor diode laser, which is heterojunction diode laser. So heterojunction semiconductor lasers are those in which p end is made up of one type of semiconductor material and the n end is made of another type of semiconductor material as gallium aluminum arsenide diode laser use direct band gap semiconductor. In this type of semiconductor diode laser, also direct band gap semiconductor material is used. In this heterojunction diode laser, there is a five layers of semiconductors. These are the five layers. In which gallium arsenide material is a p-type layer, and gallium aluminum arsenide of p-type layer, and gallium arsenide of p-type, and this acts as a active medium, and gallium aluminum arsenide of n-type n-type of gallium aluminum arsenide, and again n-type of gallium arsenide. The end faces of the third layer is highly polished and perfectly parallel to each other to reflect the laser beam. One end is partially polished to release the continuous beam. This is the construction of heterojunction diode laser, in which the upper part, this is the p type of gallium arsenide, and this is the p type of gallium aluminum arsenide, and this is the p type of gallium arsenide, and this two is n type of gallium aluminum arsenide, and gallium arsenide. And here this region acts as a active region from where a laser beam is emitted when the heterojunction diode laser is in forward biased. Now let us see the working of heterojunction diode lasers. When PN junction is in forward bias, the electrons and holes are injected into the junction region. The junction region around the junction. Sorry, the region around the junction contains large amount of electrons in the conduction band and holes in the valence band. Thus, the population inversion is achieved. At this stage, some of the injected charge carriers recombines and produce radiation in the form of light. When the forward bias voltage is increased, more and more light photons are emitted and the light intensity is more. These photons can trigger a chain of stimulated recombinations, resulting in the release of photons in phase. The photons moving at the plane of the junction travels back and forth by reflection between two sides and grow its strength. A coherent beam of laser having a wavelength nearly 8,000 angstrom emerge out from the junction region. So these are the working of heterojunction diode laser, and in this way we get the laser beam. Now let us see some advantages of uh, heterojunction diode lasers. It produces continuous wave output, and the power output is very high. And now let us see some disadvantages of heterojunction diode lasers. And it is very difficult to grow different layers of PN junction, and the cost is very high. And these are the two disadvantages of heterojunction diode lasers. Now let us see some applications. This type of laser is mostly used in optical applications, and it is widely used in computers, especially on CD-ROMs. These are the advantages and disadvantages and applications of heterojunction diode lasers. Then, okay, friends, if you have any queries, then you can ask through comment box. If you have not subscribed till now, then please subscribe and share and like to my channel. Thank you and thank you.